morning, everyone. My name is Chris Fantine, Chief Technologist at Red Hat. Welcome to today's session, the DevOps State of Mind, Continuous Security with Kubernetes. We're going to talk about container security and container security at scale. But first, back in the 90s, Andy Grove talked about how only the paranoid survive. This isn't about security, but it was about strategic inflection points when there's massive amounts of change going around a company, whether it's technology change or competition change. The company has to decide, do they stay the course or pivot and change direction and potentially thrive? And we're certainly seeing those decisions having to be made from a technology perspective right now. We're seeing massive amounts of change in how applications are being architected, how they're developed, and the underlying infrastructure on which they're run. Whether it's microservices, DevOps, or cloud infrastructure, containers are a big part of the mix. Other changes that we're seeing out there in terms of environments are hybrid cloud. Right? Applications are moving to different environments, whether it's a internal cloud or external cloud. We're seeing dev tests perhaps put on a public cloud and production running on internal cloud. These all have security implications. Also, the application architecture is moving to distributed architecture. You have application services that are on-prem, and then other applications services that are actually off-prem, and they're communicating with each other. And so the typical security perimeter is no longer contained within your data center. And as I talk with customers, especially in Silicon Valley, about their best practices with security, it wasn't too long ago when I had security discussions and it was limited just to the operations team. And typically their security best practices relied on the physical firewall as well. And certainly that can continue. We've taken a, We've taken a look at some of the greatest security risks, and employees, 36% of them are not taking the proper security measures. And another third are due to outside breaches. 14% due to unpatched or unpatchable servers, and also 11% were due to internal attacks by an employee. Shadow IT and then bring your own device were other causes or sources of those security issues. And so there's a movement towards DevSecOps. DevSecOps is all about integrating security end to end. It takes a cultural change, a process change, as well as technology tooling. DevSecOps is all about reducing risks, lower costs, speeding up the delivery, and also speeding up the reaction time to any security issues. And this is addressed by automating security, process optimization, as well as continuous security improvement. And we'll talk about how in just a moment. But first, containers in this new world are certainly a big part. And that's because they enable application portability across any provider. Whether it's physical, virtual, public, or private cloud, you can build your application once and then deploy anywhere. What about containers at scale? Developers are using containers on their laptop, but what about test? What about the production environments? And how do you manage that? And so some of the capabilities that you need at scale is scheduling efficiently your resources across your clusters and the different providers, managing the life cycle of the container images from dev into production and retirement, but also discovering the new services that are out there so that you can automatically add them into your load balancer and expand. Also, in terms of monitoring and getting that quick feedback so you can pivot and change course. Also, in terms of scaling up and down your infrastructure, being able to provide persistent storage, and also aggregate your microservices into one logical application so that you can manage high availability as well. But also security, and we'll spend the rest of the talk talking about security. So managing at scale, Kubernetes is certainly becoming the de facto industry standard for managing containers at scale, and they provide the ability to have a common platform across any provider, whether it's bare metal, virtual, public, or private cloud. You can have the same tooling, the same processes that span across these providers, increasing your
ability to safely secure your infrastructure and your applications. And so Kubernetes certainly fits into the DevSecOps movement because it provides that level of automation and the ability to continuously improve your security. Let's go through some of the basics with Kubernetes. First off, it provides orchestration, so the ability to define your application and then automatically define it in a declarative state. So in this case, I have an application that has 2 web front ends and a single database backend. And once I define that, Kubernetes Control Manager will actually go ahead and store that declaration in the etcd data store, and then go ahead and leverage its scheduler to schedule those resources. So here we're going to go ahead and schedule the 2 web servers. It's going to go find an available node and create a pod. A pod is 1 or more containers. And then likewise, it's going to go ahead and deploy the database as well. It pulls the image from either a local or remote image registry. And then it front ends them by creating services to load balance the traffic across those, as well as providing the ability for the web to talk to the database. I also, in this case, created a route out to the public internet. It also can perform health checks. So it has monitoring and logging to give you that real-time feedback on terms of how your container instance is behaving. It will detect any non-responsive containers and automatically go ahead and replace that with a replacement container instance. So in this case, the scheduler and the controller manager went ahead and scheduled another web instance to replace the down one. And then it automatically replaced it into the load balancer service so that the new traffic was being routed to that replacement instance. It also handles auto-scaling as well. If there's, you can set the criteria, so if it exceeds the threshold, it will actually provision additional capacity for that particular service. In this case, I set a limit of 75%, so if it exceeds that, it went ahead and created an additional web server. So one of the nodes went up to 80%. And here you can see it's going to go ahead and provision a 3rd web server. It's going to wait for that instance to come online and then add it into the load balancer and start routing traffic to it. So now it's updated the state to 3 and 1 in the etcd, so that's the declared state for my application. What about container security? And so we're going to talk about container security in the context of builds, images, registry, CI/CD, and then also the container host as well. So first off, container builds. One of the key things to understand as you move to containers is that the developers are no longer just providing the jar file in a Java application. Instead, they're providing typically a container image that contains the Java jar file, but also the immediate dependencies from a middleware and also OS perspective. It pulls in those dependencies. So who owns the security for these new layers that are being delivered in the pipeline? But first, in terms of container builds, what does that process look like? First off, you define a Docker file or a build file to specify the recipe for how that image may be built. It's important to note you want to specify the version and be aware of those components that you're being pulled in from a security perspective. Also, in terms of sharing that, in a container pipeline, you build it once and then you move it into test, move it into production. And so you need to store that in some sort of common registry. It could be a private or a public registry. And then running it on a common infrastructure. So the container standards provide a common image format and a common runtime to ensure compatibility, just like the Java standards as well, but for any language. In terms of the container build best practices, first off, treating it as a blueprint, the best practice. Also, the default for a container image is actually to run as root. And so you want to specify a user file. They did a survey of the public Docker registry. 85% of them are running as root by default. So make sure you're specifying that user and be explicit. Also, don't log in and configure your instance and then save it because you don't have the recipe for how to recreate that. Make sure you're version controlling your build files, and then also be very explicit with what version and dependencies that you're actually pulling in. And then each run creates a new layer as well, so be aware of that so that you're efficient from a performance perspective. In terms of the converged supply chain, in terms of who's responsible for these new layers, right? You can still carry over the same responsibility to this new world. First off, you have your typical administrator who is maintaining maybe a kickstart file for Linux can now own the base image layer from a security perspective. And then likewise, your middleware team can own the middleware layer, and then the application developer can inherit and leverage those layers so they don't have to recreate and redo the work, and they don't have to own the security for those additional layers and components. And the nice thing is also is that all three groups now can use a build file to define their layer, right? They're not using different formats or speaking the same language. From a DevOps perspective, can be very efficient and collaborative. How about container image security? We took a scan of the public repo and found that 64% of them, the images, have a high or medium vulnerability in there. So you need to be aware of where you're pulling your images from. And what's inside the image matters as well. We took a look at a few different applications from left to right. You have a C, Java, Node.js, Perl, PHP application, and it shows you the different components that get pulled into the image when you build it. In the second column, you have the Java. It's pulling in the JRE, and the little triangle has a number 66. There's 66 security notifications since RHEL 7 was released in this case. And so you want to be aware not just of the security implications when you pull down your instance, but over time as well. You need to have some sort of process to continually scanning these images. In terms of the image format, ideally you want to separate your code, config, and data so you make your images immutable. So take out that data so it's easy to scale, easy to replace, and also from a security perspective, very secure. Kubernetes provides some resources to actually store the configuration. You can leverage a config map, store an environment variable or a file, and dynamically defines that when the instance is created. If it requires encryption, you can also leverage the Kubernetes secrets to store things like username passwords. Container registry security. So a best practice, most enterprises start out their container journey by setting up a private registry within their enterprise rather than leveraging a public repo. Not only from a security perspective, but also when you're pulling in third-party dependencies, you can't rely on that public registry having that particular version 6, 12, 18 months down the road. So you want to have a copy of that in a private registry which you can control the lifetime. Also, best practice, make sure you're assigning your images. And in Kubernetes, you can check to see if it's from a trusted source, and if not, you can restrict it from actually instantiating in the container cluster. What about continuous integration with containers? How do you integrate it into your DevOps flow? So instead of delivering a jar file, as I mentioned, you're going to be actually delivering a container image. And this container image is built once in development and then pushed through the pipeline. This means that you don't go back to production and patch or edit that environment. You always go back to development. So what does the continuous integration flow from a security perspective look like? First off, you're checking in your build file into some sort of source code repository, your developers, your admins, and then you want to go to a state where you can actually have reproducible builds. Right? So why is a reproducible build important? If you have to rebuild it down the line, you get the same result every time. How can you achieve this? One way to achieve that is actually to use build images. Version control your build image, so you have a version control build environment. And then also, this build image outputs another image, your runtime image, containing just the bare necessities. So limiting the attack vector as well, and also making sure that it's reproducible. Once this image is built, you can then store it into your image registry, and then that can be shared amongst all your environments. Also, talked about making sure that you have a continuous process to scan your images. You can do this in one of two ways, typically. One is to leverage a registry which has a auto scanner every time you push to it. And then a second way is actually to just integrate it into your Jenkins, Bamboo, et cetera, whatever your CI process is, and add a stage around security. So here you can see we added a security stage, and then it could run one of the scanners. There's a lot of open source tools like OpenSCAP, there's Claire, also other vendors like Black Duck, Anchor have scanners as well. Some do vulnerability checks, also some have security policy checks in addition, or offer a deeper inspection. Continuous delivery with containers. So how do you manage containers at scale, right? My application went from a single monolithic application, now I may have like 10 microservices. From a security perspective, how do I ensure that my environment is updated when there is a security concern? And so Kubernetes helps out in that regard. It has built-in deployment strategies. And there's a variety of them built in, so you don't have to write your own scripts. You free up your developers to focus on coding business logic. And today we'll talk about recreate, rolling updates, and blue-green deployment strategies. So first off, recreate. This is a way to update your environment in a very simple and efficient way. First off, here on an example, I have version 1 deployed out into my cluster. There's a security issue. I need to get version 1.2 out there. How do I go about doing that? Well, with the recreate, I actually bring down my existing cluster, CI testing, and then actually, excuse me, and then deploy 1.2. So the use case for this is non-mission critical, right? I don't have to worry about downtime. It's okay to have downtime. And simple and clean. I don't have to worry about backwards compatibility from a schema perspective. I don't have to worry about backwards compatibility from an API perspective as well. Next deployment strategy is rolling update. With the rolling update deployment strategy, I have version 1 out there. And in this case, I need to ensure I don't have any downtime. So the rolling update allows me to actually build out version 1.2 and then incrementally roll it out and replace the existing instances. The nice thing with Kubernetes also, it has a health check built into it. So as my new version comes up, I can do a TCP, HTTP, or run a script to validate that that new version has connectivity, for instance, the web to the database before I add it into rotation. And I can gradually roll it out as I gain more confidence in the new version and make sure that it doesn't have a negative impact on my business. What are the advantages of this particular model? One is I can horizontally scale if that has a nice architecture. Also, in terms of backward compatibility, I need to write that in, so the developers need to be pulled in from an API and a database perspective, and have 2 versions hitting the data at the same time until it goes to 100%. Also, this is great for zero downtime, and I can reduce risks in terms of ensuring that my environment is always there. And if there is an issue, I can always roll back with that from the new version to the old version at any point in time. Deployment strategy, blue-green. Right? Blue-green deployment strategy is where you have an existing blue environment, for instance, version 1, and then I have a green environment, right, 1.2. So I set up an entirely new environment for that new version. I didn't make any edits to my existing version. I can put it through CI testing, and then once that's complete, I can actually flip the traffic by changing the load balancer. The nice thing about this is I never edited the existing environment, so it's easy to roll back. Right? I have high confidence. Also, the green environment is a mirror of my blue environment. So I have high confidence that this new version will be successful as well. And then I have zero downtime. Right? So if there is an issue, I can do a rollback to the old one because it still exists without any changes. The negative here is that I have to have additional infrastructure to support both clusters. I can put it on the same physical, but logically, there's a duplication there. All right, what about this movement towards microservices? How do I enable my developers to rapidly innovate and experiment and try things out with a container environment? So first off, microservices, really all about innovating, moving fast, and experimenting. But you know, there's a quote here from Microsoft about how only a third of the ideas actually improve the metrics they were designed to. So it's important as you move to Microsoft to be able to facilitate and automate the ability to experiment and try out. And Kubernetes does this in a couple of ways. It helps out. First off, it provides a feedback loop to your developers and operations on the environment. You know, is the container instance responsive or not? Secondly, it provides the ability to do A/B testing. This is where you have version A deployed. In this case, I'm trying a new recommendation engine on the right, recommending different products. It also could have a security update as well. And I want to get real-time feedback on this change. Is it negative or positive? And so in my Kubernetes cluster, I can leverage canary deployments. This is where you have version 1 in production, and I'm monitoring, in this case, the conversion rate based on how many people are actually clicking on one of the recommended items. And so in this case, it's 25%. I have a security issue. I'm going to roll out that in a new update. I want to make sure it doesn't have a negative impact on my business. So I could do a canary deployment. This is where I roll it out to n number of nodes in my cluster, in this case, half of them, and on a monitor what the impact is from a business perspective. In this case, it actually had a positive impact of 30%. So it actually improved my conversion rate. In this case, I'm going to go ahead then route all the traffic to that new version. However, if I had detected that it actually had a negative impact, I could stop the rollout and revert back to the previous environment. What about container host security? So containers are Linux, and Linux provides several capabilities to ensure container security. First off, cgroups provides quality of service, so you don't have a noisy neighbor in terms of network, memory, storage. Namespaces. There's user namespaces, network namespaces. This provides logical separation of the containers. For instance, your user IDs, GIDs in a container are unique versus the host. So if you have a root user in the container, there's a security issue. That is not the same as the root user at the host level, and user namespaces provides that. Likewise, network namespaces provides network isolation, so you can have 13 apps on a single host with 13 isolated networks. SE Linux provides mandatory access control. So even if a container running as root still has to be explicitly stated or whitelist of what objects it has access to. SecComp allows you to filter out what privileges from a container or a kernel perspective that a process has. So if you know what privileges a process needs, you could just whitelist just those. And then also read-only mounts. So things like /proc are limited to being read-only. All right, some best practices in terms of the container host. First off, don't run as root, limit SSH, use namespaces, define your resource quotas, make sure you're enabling logging, apply security rata, not just the container instance, but also the host, and be sure you're applying the security context with SecComp filters as well. That's built into Kubernetes. All right, and then lastly, at the bottom here, network isolation, storage, API access, monitoring, and federated clusters. We'll go through these. First off, network isolation. So I mentioned network namespaces. This allows you to have multiple environments in Kubernetes. I can have a mirror of my production environment on my laptop in my development environment. Likewise for test. Also, I can enable multi-tenancy, so I can have the 13 apps, 13 networks on one host. Kubernetes also allows you to define network policy. Right? This allows you to explicitly restrict one service talking to another. Storage security. First off, you can set security context constraints, so certain instances are limited to what they can access from a storage perspective. I can also define a storage quota so you don't overflow the storage and cause negative impact. From an API perspective, Kubernetes provides an API, and you can set authentication to that through an LDAP or auth provider. There's also encryption on the network as well. And then also you can define user roles to limit the capabilities that they have in the Kubernetes API. Also, monitoring and logging is a key part of managing your cluster at scale. The logging provides a central way to collect all your logs, and you can put it in something like Splunk. You can also use the Elasticsearch to search, and when you're debugging or trying to identify security issues as well. There's real-time monitoring built in with Prometheus. You can use Prometheus to provide those metrics and store those metrics from an auditability perspective. And then federation. So federation allows you, from a security perspective, to define different clusters with different security privileges and be able to route your applications to the cluster that meets the specific security requirements for that application and service. So you may have a different security level on your Amazon cluster versus Azure and your OpenStack environment. So what's next? Above Kubernetes, it's all about managing the microservices as you move to cloud-native applications. And so there's a strong movement towards having a service mesh. Right? Now, as you move to application architecture where you're moving away from monolithic and internal communication between your three-tier architecture, you're moving more to a distributed model where maybe you have 10 microservices spread around multiple providers. You need to be able to manage what's called the service mesh. Increase network traffic spanning across different providers. And so Istio is a solution that allows you to actually manage that. That's an open source project. It provides the ability to do monitoring and metrics at the service level. Also provides access control and usage policies to restrict one service talking to another. It also enables you to do fault injections into the service to experiment and try things out to see if those services would fail. Also to main goal is to actually route your traffic, right? To do things like a circuit breaker so that a single microservice doesn't bring down your entire application. Also, you can do A/B testing of your services and to do traffic mirroring. Right? Traffic mirroring is really interesting because it allows you to actually mirror your traffic from production into your test environment. So now I can actually test with real live traffic. I'm going to be more confident as I deploy that new update into production because it had real testing with real traffic. In terms of encryption, it also allows you to manage your certs in the communication between service to service and rotate those out as well, so providing some automation around your certificates.
Chris?
All right, so
We're out
with
of
that,
time. I'm sorry, we're running out of time.
so with that, I want to thank you for attending today's session. Feel free to reach out if you have any questions. See Vantine at Red Hat and Twitter. Thank you so much.
Есть вопросы?
Sorry. Chris, do you have a moment for a question? Yes. So, first of all, thank you for your presentation. And have you had the chance to look at Amazon's new offering in managed Kubernetes, EKS, yet? How would you evaluate its security state? Is it production ready, or maybe not?
I'm not, you'd have to ask Amazon if it's ready for production, but you can certainly, in terms of Kubernetes, you can actually install your own cluster, and that, could certainly be production ready.
Yeah, so I was just wondering, how would you evaluate its sort of integration with IAM roles, for example? Is it something that we should do on sort of other clusters as well, using role-based security? Or is it a bit overkill for smaller clusters?
Sure. So, I mean, from a Red Hat perspective, we offer a fully managed service on Amazon, so it's called OpenShift Dedicated. And then we also offer the ability to install your own cluster and integrate with your auth provider to provide that authentication.
Okay, thank you.
Еще вопрос?
Hello, thank you. You talked about SecCom filters, and I want to know how do you enforce them? Is some base template for SecCom filters, or you're picking specific for every service, or how does it work? SecComp. Yeah. How do you enforce? Is it specific for per application? Is it have some base level for all your services, something like this?
It's per process. So you'd actually have to define, there's a couple dozen or so capabilities in the kernel, and you could actually restrict which ones that
Yeah. I know how SecCom filters works. I just want to, how do you enforce it in your production, and how do you work with SecCom filters? So, for example, you have some developer, and does he know about that there will be some SecCom filters, or don't? I don't know.
Oh, sure. Yeah, they would need to know and define that for your instance. Yes. Just similar to like SE Linux policy.